Davidosimo, and I am chairing this session. I will give the floor to the different speakers. This is one of the many webinars we are organizing in the EU Data Landscape project, and this one obviously focuses on how farmers make use of big data. We have had many other webinars addressing topics such as finance, such as government, and one of the future will be actually on data-driven innovation in the public sector. This webinar is about how farmers make use of big data to increase their competitiveness, and its particular interest is, as you can understand, because of the very traditional sector that we are talking about. The webinar will last 1 hour. We'll finish at 4. Let me talk to you a bit about how we are going to organize it. So the idea is that we start after my introduction with Stefania Guzzi from IDC, who will present the overall project that we are carrying out for the European Commission. Stefania will then focus on the results of their analysis of how data-driven technology are changing the primary sector, and particularly on precision, what we call precision agriculture. Then we will have a case by Lucia Confalonieri from Salt and Lemon about risk farming. And then we will open a question and answer session and summarize the results of this discussion. I would like to point you to the fact that you have the possibility to pose questions to the speakers. So there is a question section on your dashboard, and I will take care that the questions are submitted to the relevant speaker for providing an answer. You can submit a question anytime, but the questions will be answered after the presentation. Obviously, this is a webinar, so we cannot have a real-time interaction. But after the presentation, not only your questions will be answered, but if you want to make a point, a structured intervention, you will be able to make it. We will give you the floor. You just have to raise your hand. You will see there is a possibility to raise your hand. You see the button probably together with all the other buttons. And if you raise your hand, we will call you out and ask and give you the floor. That said, should be pretty straightforward. Let me just remind you that all the results and the video recordings of the webinar, together with the presentation that Stefania is going to present, will be available on our website, datalandscape.eu. Hence, let me just give the floor now to Stefania for an introduction of the study and a presentation of the particular results on precision agriculture. Stefania, the floor is yours.
So we are here today to present what we call the precision agriculture case study that has been developed in the context of a broader project that is the European Data Market Study that is carried out by IDC and Open Evidence for the European Commission. With the overall goal to define, assess and measure the European data economy up to 2020, and with our finding and policy recommendations to support the European Commission's value chain policy. The overall focus of our analysis is on the data market, that is an emerging market that is still in its evolution phase, but already has demonstrated to have a strong growth potential, and as a consequence is attracting new actors, new companies from also other sectors, and supporting the development of new business models. To carry out our analysis, IDC and Open Evidence have developed two main analysis tools that are the European Data Market Monitoring Tool and the Data Landscape Community website. IDC responsible for the measurement of the monitoring tool, that is a set of indicators that takes into account the data economy in its entirety, and by measuring 6 areas of concern. So you can see in this framework these 6 measurement areas we take into account, from the number of data workers in Europe, to the value of the data economy, to the benefits for citizens thanks to the adoption of these technologies. And this measurement is also forecasted to 2020. In parallel, Open Evidence is the responsible for the building and managing of the stakeholders community, with the aim of establishing a connection with the main stakeholders in this field, to reach out new stakeholders, new players, and to disseminate the project results. The monitoring tool and the stakeholders are 2 of the 3 objectives of our studies. The third one is about the production and dissemination of what we called stories, that are descriptive analysis, taking into account and investigating different aspects of the society and sectors of the economy where these data-driven technologies are bringing innovation and values. For example, through the descriptive stories, of which the precision agriculture we are presenting today is an example. In our study, we have already identified different sectors that are benefiting of positive impacts, and where the data-driven innovation is bringing value to the organizations and is bringing tangible impacts. For example, in the retail, our analysis confirmed that tools for predictive demand analysis and delivery improved the sales process. We also investigate the manufacturing, where the data-driven technologies are helping productivity increases and improving the factory processes. Also, it is important to say that the public sector is also benefiting of these innovations thanks to the BDA technologies that are proving public services for citizens across Europe. I'm going now to present the precision agriculture case study. The widespread availability of data-driven technology in different sectors of the economy I was presenting before has rapidly reached also the primary sector by transforming the traditional farming management technique based on a smarter observation of crops, real-time resource monitoring, and an intelligent predictive decision-making. In this context, precision agriculture represents one of the most promising and effective new technique, and is already providing solutions to a large number of challenges that are affecting the primary sector, like the rising demand of food production, the effects of the climate change on the environment, and the growing global population. In this context, thanks to a set of innovative tools and technology, agriculture agriculture is moving from being a traditional sector, an ICT laggard, to a world of opportunities for business and organization. This is also confirmed by available sources providing figures on this market, according to which Europe is playing a key role and is globally positioned very well, being the second market after the US player. These figures say that the European market is growing at 15% growth rate up to 2020, when the market will worth about 1 billion euros. To foster this growth and support these opportunities, both public organizations and private entities are launching initiatives and increasing their interest in this field. For example, in our analysis, we identified public initiatives like the UK government supporting the innovation through its innovation agency, the Ireland that has recently established a strategic investment fund in agriculture, and as everybody knows, the Germany's industry program, Industry 4.0, has a special focus on agriculture. Besides the public sector efforts to foster innovation in these fields, also precision agriculture is demonstrating to be attractive for the private sector. Several private investors are moving their capitals and their money to this domain, supporting the creation of a new business model, driving the creation of what we call the agri-tech startups, with some special focus on subsectors of the economy, like the growing food e-commerce market, the drones and robotics technologies that are the most representative technologies of precision agriculture. And so what happens when the data comes to the farm? With the term precision agriculture, we refer to a mix of digital technology, database technologies that go from robotics and drones to big data and analytics, to IoT and sensor, and including cloud computing and mobility solutions. Their main advantage when we come to the farm environment is that these technologies make it possible to collect and leverage a huge amount of data and make farming operation more from a traditional sector, traditional environment, to a more insights-driven and potentially more productive and effective. The positive impact of this kind of technology is that precision agriculture can be applied to every step of the farming supply chain. So farmers can take advantage from the activity like season planning to the planting phase until the harvest moment, with positive benefits like pests control and management, a smarter fertility program for the crops, and market-oriented analysis of their production. What we did in our analysis, once we understood what was the environment where precision agriculture was bringing innovation, we were able to identify several impacts of this innovation. For example, as I said before, one of the major impact for this traditional sector is that these innovative techniques are really transforming the decision-making process with predictive analysis capability that are insight-based and can support the farmers, processes along all the supply chain. In terms of quantitative impacts and savings, we understood that farmers can benefit from a smart use of their limited resources like water, and also from a smart use of fertilizers, and this is also having a positive impact on the environment. Precision agriculture can have also economic benefits in terms of productivity and profits. We were able to identify a real case, interesting case of application of these innovative tools. We involved Salt and Lemon, that is an Italian company operating in this field. So I would leave now the floor to Lucia Confalonieri from Salt and Lemon to present their case study.
I will now pass the floor to Lucia. Lucia, normally you have the floor. You should activate your audio, and here you go.
Okay, perfect. So let me start with a brief introduction on precision farming, or precision agriculture, as you can call that. First of all, this is not a new issue. Precision farming exists since the 90s. In fact, it was born in the US for huge corn and cotton crops. At that time, but even now, it refers to a set of technologies and methodologies supporting agriculture management strategies. So, in summary, what it means to do the right thing at the right place at the right moment. It means how much nitrogen, which is the major component for fertilization, how much water, how much pesticides I need to give to my crop to improve yield in terms not only of productivity, but also in terms of quality. Obtaining at the same time cost reduction and, of course, a decreased impact on the environment. There is a key technology that has been used since the 90s in precision farming, that is the infrared technology. These slides refer to the activities that we have performed in the last 3 years, but I want to before going to this, I want just to tell you something about the infrared technology I was talking before. So the infrared technology was available and became popular through satellites, and particularly through the availability of Landsat. It is very popular constellation of satellites launched around 30 years ago. It's based upon a physical phenomenon according to which the crop is sensitive, thanks to the chlorophyll component, is sensitive to the infrared light. So when you take an image of a healthy vegetation, a healthy crop, that means a crop retaining a high amount of chlorophyll, the image is very brilliant. So according to the level of color, to the color of the vegetation, you can understand the health status of your crop. This is the phenomenon. So the availability and the big phenomenon of UAV combined with the infrared technology has made a big push to precision farming, because first of all, UAVs are much cheaper and more flexible than airplanes, and are more viable than satellites, because satellites have the problem, hold the problem of atmospheric condition. If it's cloudy, you cannot get the necessary image. But there is a big challenge for UAVs in precision farming, and it's the integration of different expertise, different skills. As precision farming requires what we can define as multidisciplinary approach. Avionics and flight experience, sensors that should be adapted to be carried by drones, data processing, software data processing, particularly geographic information system through geostatistical analysis, and physical and chemical issues that should be handled typically at lab level. So given all these different aspects, as a company focused on UAV, but interested in providing a solution to precision agriculture, what we did was to put in place a network of partners, each one retaining a specific competence, the one I was mentioning before. So our typical partners are a GIS software company, agronomist, a research center, and a university department focusing on agriculture. Let me add that the inclusion of academic bodies like a research center or universities is key, because precision agriculture is still a field of research. There are so many issues that still need to be investigated. So the experience our experience started in 2013 in rice crops for optimization of rice fertilization distribution. But the first 2 years, so that means 2013 and 2014, we have been working to define and validate a methodology. Just to give you a hint how difficult is the process. So this was a key step, because we were acquiring data from our UAV, so from our flights, but at the same time, the research center and the university were collecting data at ground level with an equivalent sensor, and we're making a lab test to see if everything was consistent. And the result was quite encouraging, because the results obtained through different methods were arriving at the same point, the same level of conclusion. So, and another point, all these tests, both the flight test and the lab test and the ground test, were done in the experimental fields of this academic research center that is called Ente Nazionale Risi. So with this kind of result, in 2015, that means last year, we were involved in a project financed by Kellogg's with the goal of bringing this methodology to the real, in a real case, in a real crop, in a real farmer, by real farmers. So what we did was to go beyond, not only to do the real project, but also to go beyond the result obtained in the trial phase. That was mainly the provision of vigor maps. So in 2013 and 14, what we obtained were vigor maps. That is to say, software maps detailing for each selected area the health status or vigor. That is an index, is a number. It's called, it's an index, a mathematical index called NDVI, providing this index for each selected area. But this was not enough. I mean, this gives you a quantitative analysis of your field in terms of nutrition requirement. But what we did then was to relate this to the exact amount of nitrogen of fertilizer to be spread. So what we did, we arrived to the provision of prescription maps that were given to a special machine called a variable rate tractor or variable rate machine, provided with a GPS, so able to read the map and distribute the exact amount of fertilizer in the right place. But we went even beyond, and during the harvest phase, we were measuring, weighting the production in terms of rice on each selected area. So and we obtained the so-called production map. So the three maps, vigor maps, prescription maps, and production maps, are at the end are able to quantify the result in terms of economics. So that means the number that you can see. So this is the maximum level we achieved: 30% reduction of fertilizer, 50% improvement in productivity, and let me say a very fast job in terms of time required to do everything, to do the flight, to do the data processing, and the physical distribution. There is another saving that cannot be quantified, but is very important, because we realize that in case you distribute too much fertilizer, the crop can get a disease, and in this case you have to give them what is called as plant protection product, so something to protect the crop. Not only, the result in terms of sustainability is very high, because of course an excessive amount of nitrogen can really pollute the water. So this is, for Kellogg's, by the way, this was one of the major goals to reach. And of course, using UAV, you don't, because you can do the same thing with the sensor put at the side of the tractor, but this is very slow, is not so accurate, and is very invasive. It's very it can damage the crop. So given that, we think that the major feature of this experience was to demonstrate the possibility to bring something related to the research environment to the market, first of all, and transform this in a viable product, in a viable service, first of all. Second, it's quite easy to provide facts and figures so that the farmer can easily calculate the return of investment. And this was, let me say, the big result of the project. But what we are very proud of this result. So what we have in mind is to go beyond and expand to different kinds of cereals. This year, in 2016, we are doing the same, not only for rice on an even larger scale, but also for barley and wheat and corn. And also to use an equivalent methodology with similar partners for different issues like water stress, so how to measure water stress in order to distribute the right amount of water, which is a key issue for example corn, but not only. The second area of investigation will be the area of diseases. This is quite complicated, and in this case, as well as in the case of water stress, we will use a different technology, not the infrared not the same infrared that is called near infrared, but the thermic infrared, because the physical phenomenon in that case will be the measuring the exact differences, very small differences in temperature. In this way, we are confident, because we know there are already many clues, many hints of it, that through the infrared, thermic infrared, we will be able to assess all these issues, the stress, water stress, and different kind of diseases. So this will be our next plan of activity. Okay, I think I've finished. If you have any question.
Thank you very much. This has been extremely interesting. I really enjoyed especially the conclusion that perhaps could be applicable to other sectors. So big data is not only a useful instrument, but also it's a technique and a tool that provides clear evidence of its advantages. And in itself, this is an advantage that big data has compared to other forms of innovation. So that was certainly inspiring also for the other sectors we are working on. Now, there is one question mainly coming from the audience at this stage, and it's related to overall market growth estimation. Stefania and Giorgio, I know you, especially Giorgio, has worked a lot on this previously. And the question is the following. Is from Donat Maghiari, is that we cited Roland Berger market growth estimation. Do you have up-to-date forecast or your own IDC prediction to share? Stefania or Giorgio, can you answer this?
So I can try to answer. Well, if the question was referring to especially the precision agriculture market, the Roland Berger report is the source we have used for to get market figures for our report precisely on this field. So we rely on the figures reported in this source that is quite recent, and we have used the market size to give a context of the market we were analyzing for precision agriculture.
Thank you very much. I'm also posting an answer to all, because obviously Stefania answered about precision agriculture. However, you should know that the study has published a wealth of data, not on precision agriculture, but on big data in general. And yes. I will just now send to everyone in the chat and in the answers the link to, so that you can download the study if you wish so.
Yes, as I was saying, the what we call the monitoring tool is the group of indicator we are using to measuring these big data and data market. So for 6 areas of the data economy, we are able to provide figures on the growth up to 2020. For example, we are measuring data workers number, the data companies, the number of data companies in euro, the value of their revenues, and other indicators like the value of the data economy and the data market, and also the gap between the demand and supply of data workers in Europe. So you can find all this data in our report.
Thank you very much. I have a question for Lucia. Lucia, you mentioned that big data and precision agriculture provides not only the instrument to innovate, but also nice instruments to measure the impact and the benefits of this innovation. Do you think that this certainly facilitates uptake, but do you think that this is common to other sectors, or a specific thing for agriculture? The fact that basically big data, it's easier to make the business case for big data.
No, in fact, can you hear me first of all? Yes. Can you hear me?
Yes.
Can you hear me?
We can hear you very well.
Okay, thank you. No, the answer is that this kind of approach can be extended to further sectors, like, for instance, the energy sectors. There is an issue which is very important nowadays, that is the so-called power efficiency. So to avoid energy wastes. So in this case, a drone or UAV is equipped with a thermic camera, so a thermic infrared camera that is able to, according to the same phenomenon I was describing before, the difference in temperature, is able to record the heat waste, for instance, on a roof of a building or on a facade of a building. And this is something, so there is a lot of images that are collected in the same way through the flight. Then they are analyzed and processed through a special software. And then they should be interpreted by a sector specialist, an expert in thermography. And at the end, what you get is a report that can be used for the customer, that can be the end user or an architect or an engineer on whatever. So the approach is quite similar. What it changed, of course, is the sensor that is slightly different, because the physical phenomenon is different, and the professional that is in charge of interpreting this kind of data. Differently from agriculture, this kind of technology is more developed in the sense that it is normally used by people, by personnel that is holding these kind of cameras and is performing the activity. But of course, it's much less effective and it's much slower and more dangerous, because you need a human being holding the camera, and you cannot reach dangerous places and so on. So, and the process is much, much slower. So if you use an UAV equipped with the equivalent sensor, you reach a much more cost-effective result. And this is an example, but there are others.
Many thanks.
Photogrammetry is another example. Mapping territories. It's photogrammetry. It's something that has been developed through airplanes, but once again, it's a much more expensive mean compared to a UAV.
Thank you very much. Now we have an additional question from Robert Langer for you, Lucia. What are the current problems in precision agriculture, and what kind of technologies are needed to address the current problems in precision agriculture? So I think it's really about what's next.
Yeah, I can expand a little bit on what I said before. Fertilization, it's one issue, major issue. But another major issue, of course, is water distribution, because everybody knows that water is a very key sensitive resource. And the major issue, of course, is in agriculture is diseases, because there are many different kinds of diseases, and an early comprehension of the phenomenon, an early observation of the phenomenon can really help. And because of UAVs are so flexible, and it's not like an airplane that you need, it's expensive and it's big and so on. You can use it whenever you need. Of course, you need a specialist. So, and at this point, we will get into a more complicated issue, that is the regulation issue, because in Italy, but not only in Italy, every country has his own regulation. Hopefully, at the end of the year, beginning of next year, we will have a European regulation. But we have also a proposal of partnership for farmers that are big enough, or an association of farmers that want to deploy these tools by themselves. This is possible. To comment again on this, on the question, I can add the issue of vineyards. Vineyards is a high quality kind of agriculture, very expensive, but very productive also from the economic point of view. So there are many things that you can do for vineyards, like for instance to provide information for the harvest, the best harvest timing. So to decide according to the level of ripeness of grapes, when is the optimal harvest time. And this is another topic that you can address with with UAVs in precision farming, or the census of a huge wood area, wild area. You have to classify or to count the plant in a selected area, particularly big, of course, and in that case you can use a UAV equipped with a high quality, high resolution, very high resolution, Ultra HD 4K camera in the visible band. So this is another example. There are many. Agriculture is very open to as many aspects that can be investigated through UAVs.
Excellent, many thanks. Last question for you, Lucia. Are you happy with the current infrared technology that you use? What problems did you encounter? And just try to be very synthetic, because I'm sure this is a very important topic, but not for all the participants. So.
No. Yeah, it is a good question. We have reviewed 3 different near infrared cameras. At the moment, we have chosen one that provides also not only the infrared, near infrared, but also the red edge, and we are happy on that. Yes, we tried 3 of them. The first one was a plain modified RGB camera. Then was another multispectra. Of course, when I'm talking about these cameras, I'm talking about multispectral cameras. And we are now using this near infrared plus red edge, and we are quite happy, yes. Of course, there are also hyperspectral cameras, but they are still too heavy to be transported by a UAV.
Excellent. Just another question, Robert, I didn't see before, regarding the right timing of harvesting. Does this apply only to wine or also to other crops, and which other crops?
Well, it can apply to many kind of crops, of course, because it's a typical agricultural phenomenon. But vineyards, grapes, it's it's a quite expensive and productive in economics term kind of crop, so they can afford a further investigation even at that phase. So that's why they are very very specific for each phase of the growth of the crop. They have a specific action. That's why until now, since now, they are using this kind of analysis. But the same can be applied. It's just a question of costs, of course.
Excellent. And with this answer, I think we can close it, because it's an answer that also applies to other sectors, of course. So it's the idea is that you have to focus the intervention where the benefits are higher, and this is why in agriculture it's about wine, and this probably there are some lessons to be learned also for other sectors. So on my side, I would leave it here. I would just say thank you to all, and I learned a lot, and I'm sure people watching in the video will also be enjoying. So look forward to seeing you in the next webinar. Thank you very much.